Hello there student, how's everybody doing? I hope you are doing well. In this video, I'm going to talk about absolute value and absolute value function. Here, this is important to talk about it, which is absolute value functions is an idea and a concept that reflecting distance. Distance in mathematics cannot be written with negative numbers. We have to use positive ones. So here, we say that we can give absolute value negative numbers. So be assured about that. This is what it's talking about it. Now, the example one is reflecting some ideas. I will not be talking about it. What I'm going to talk about, how can we answer them like this? So first thing, here it say calculate these values, okay? So how can we calculate it? First thing, we start with this one here. We got an absolute value that's say 9 minus 5. What you gotta do, you just simplify the inside, you give 4, and absolute value of a positive number or of a positive value, it's just the value itself, which is 4. Same thing, we get 4 less than, or you can say smaller than 6. So we subtract it and we get negative 2, okay? And because absolute value remove negative signs inside of it as a content, so we get 2 as an answer, okay? That's the answer. Now let's go for this one. An absolute value of a positive value, doesn't matter is a fraction or not, it's just the same thing without the absolute value, like that, okay? Now here it's some rules that you should know and understand it. I will not be talking about it because we will be applying it in examples, and most of these rules has not been mentioned or used in the book here. So basically it's useless without applying it. But what you gotta know is that these rules can be applied later on when we are dealing with ideas that need more steps. Now what is important is example 2 that you should understand. In example 2, the teacher says that without using the absolute value symbol, so which means that you can use absolute value symbol, what you gotta do, you have to redefine this in a different way, okay? Basically, this been answered. I'll not be talking about it. What I'm going to do, I'm going to use this example so you as a student can understand what is going on. Our concept is absolute value of x minus 3. The teacher asked us for redefining it. So what are we going to do here? I'm going to write absolute value of x minus 3 in 2 ways, okay? We can write it like that. First way and second way. The first way, it should be positive, like that, without any change. In the second place, we got negative and x minus 3, like that, okay? Now, we have 2 cases. The first case is that the x minus 3 is bigger than or equal to 0. In the second case, x minus 3 less than 0. So we need to change that condition here. This is the condition part. That is the function part that we should use. So what I'm going to do, I'm going to take first the inside of the absolute value, which is x minus 3 here, like that, equal it by 0. Then, as you know that the place of the 3 will change and become, on the right side, become positive. So we get x equal 3. Okay, so what we gotta do now is this. I'm going to write the question again. Absolute value of x minus 3 in 2 ways. The first way will be x minus 3 and negative x minus 3, like that, where in the first place we got x bigger than or equal to 3. The second way, x less than 3. So what we done is the same procedure. That's how you redefine a question. Now, another thing that you should know as a student is the absolute value and analysis of absolute value equations. When we talk about absolute value, when we have a number, let's say 2, as you see it here, sometime when the content of the absolute value is not given, for example, you have x, you don't know what is x, but they say that x is, or the absolute value of x equal to 3. This means that maybe the x was positive 3 that resulted to be x equal to 3, okay? Or in this position, or the x was negative 3, and when you took it outside, the absolute value became x equal 3. So that's the case regarding this idea. Now, here it says that different form of absolute value function. Another problem regarding this book is that most of the ideas, most of the title are mixed together, and the reader is struggling with understanding what is going on. So in this case, you need to understand. Here it says that different, that's the title, different form of absolute value, like that, value function. That's what's talking about it. Absolute value functions like that. Okay, that's what's written. Here it says that if we have an absolute value of x, we will be having something like that. Okay, this is the condition, that is the function. Now, regarding this one, I have a lot of comment to talk about it or say it, because in here, three, or you can say two ideas not being mentioned before. One of them is the symbol of function, f of x, and the other one, which is linear function. Linear function, you can say the organizer had to know and prepare some ideas so the student can understand and what to do. So what I'm going to do now is this. F of x equal y, and this is mean a function, okay? Now, when we say the linear function here, linear function, we are talking about a function f of x equal only x, okay? And the only x here that we have it is that the parent function for linears, because from this function here, the other are being created. Now, here it's talk about three condition or three situations that applying in here. So first thing they talk about, if we had a function of f of x inside the absolute value equal to a constant, okay? In this position, we have three cases. The first case is that if this is positive, or you can say positive number, or you can say positive a. If this is the case, the f of x has two solutions here, plus minus a as an answer. However, if this one is negative a, and by the way, this means two solutions, but if it's negative, it means that no solution, and no solution, and by the way, you write it like that, negative a and a in the set notation, but in this case you have an open set, or you can say an empty set here, just like that, okay? The last case that we have it here is that if a is 0. So if a is 0, you have f of x equal to the 0, and this means you have one solution, and the one solution mean you only write the answer of that one here, okay? Now they gave an example. I'll not be talking about the example, but I'm going to solve this one here. It says solve this and equal the solution. Another problem here, dear student, which is the titles are not 100% true. They didn't use the proper words to answer the question here. So first thing, you need to change these. It says solve this and check the answer, or you can say the result. So what I'm going to do, I'm going to open a new bracket, or you can say open a new page. I have 2x plus 3 equal. Now we are going to solve this one here. First thing we should understand, this is a positive number. So I'm going to open and write it in two ways here, okay? The first way, which is 2x plus it by 3 equal 1, and 2x plus it by 3 equal negative 1. We simplify it, we get 2x, the 3 goes to the other side, become negative 3, and we subtract it and we get negative 2, then we divide it by 2, we get negative 1 as an answer. Same procedure, we have to do it -1, -3, 2x equal -4, divided by 2, we get x equal -2 here, okay? So what I'm going to do, I'm going to check my answer. Checking process is applying the numbers in that absolute value. So in this case, I have 2 times it by -1 plus it by 3. I should have 1. Okay, I'm not sure about the answer, so I'm going to put an what you can say, a question mark on it. So here we get -2 plus it by 3. Is it equal to 1? We don't know. So absolute value 3 minus 2, we get 1. And yes, it's equal to 1. So this one is true. Same thing for this one here. We get 2 times -2 plus it by 3. We are not sure about if it's 1 or not. Same thing, we get -4 plus it by 3 equal 1. And we subtract, we get -1. We get 1. And absolute value of -1 is 1. So in both cases, which was true. So our answer is true. Now we have the following question here. Again, the title is not correct. You should, for example, say solve each equation if possible, not if they have a solution, if possible. Possible mean that you have an idea or have an answer. So what you gotta know that first thing, when you have a situation like that, you don't need to do anything else. You just put this one to the other side. You say you get x plus 2 equal -1. So because this is negative, already you say no solution, and the solution will be an empty space, okay? For this one, you get 1 because this is 0. Now I'm going to answer this question here so you can see. It say that solve the equation and evaluate the solution. Again, it's not evaluation, it's checking your you can say checking your answer, your solution. So what I'm going to do, I'm going to bring the question again. Absolute value of 3x plus by 6 equals 0. Now I'm going to remove the absolute value. I get 3x's plus 6 equals 0 here. Okay, so now the 6 goes to the other side, become 3x equal -6. Now I'm going to divide both sides by 3. I get -2. Now I'm going to check my answer. Check. By putting it back in the question, we get 3 times it by -2 plus it by 6. I'm not sure if it's equal to 0 here. So we get -6 plus by 6 equals 0. And the absolute value will be 0 equals 0. So 0 equals 0. So the answer is true. Moving forward to something that's called graphing absolute value functions. Again, the graphing procedure, guys, it's important to be mentioned before, but the book didn't mention it. So what I can say is that to graph any function, doesn't matter what is it, you can use the method of giving inputs into the function and producing the result or the output. Now here it's talk about that. Previously discussed that this is absolute value equation, which called main parent function. Based on that, we have other graphs. And what you should know about range and domain here, it says that domain is all real numbers and uses the x value. The range is second y-axis, so it starts from the head of the sketching until the infinite. What is important that you should know is that here it says that draw the graph of the equation and determine its domain and range. Already the graph was created from the point, and it said that the domain of the graph include all real numbers. However, observing the graph, we see that starting at y value of 1, so it starts from here, meaning the range is y bigger than or equal to 1. And what I'm going to do, I'm going to answer this one so you can see the procedure regarding the question. So it says that draw the graph of the equation here and determine its domain and range. Okay, so now what we are going to do is this. I'm going to open a different page here. The function that we have, it say y equal minus absolute value of x plus, I think was 1. Let me go back to, actually it's 2. So we are going to write the 2 here like that. Now, as I told you, y mean f of x, okay? So in order we can graph or make the graph of this function, what we are going to do, we are going to create a table consisting of 4 parts like that, okay? Or you can see 3 parts, doesn't matter. So x, the function which is f of x, and the y. X is input, you are given it 2. Y is output, what you get as a result. And given the points, in this case, you can give any number you like, but here they give -2, -1, 0, 1, and 2. Given those number is optional, but always choose smaller number next to 0 so you can graph them. So in this case, I'm going to write down, we can use the -2, -1, 0, 1, and 2 again to try and graphing the function here. So what I'm going to do, I'm going to put these number in the absolute value here. So first thing we got the negative, we get -2 plus it by 2 equal. So the absolute value that contain the -2 will produce in 2. And, well, let me make it like this. So we get negative and we have an absolute value of 2. Absolute value of -2 to become 2, and to 2 you get 0. So the y is 0. I'm going to put those points on a graph of the coordinate plane like that. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 in negative. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5 here. This is positive 1, 2, 3. 3, 4, and 5 here. So in the bottom part, we don't need it. So here, let's say that -2 and 0. So -2 and 0 will be in this part. For the domain, always the domain is real number, okay? Numbers, real numbers, okay? And the range, we see it's on the 2. So it means that 2 bigger than or equal to y. That's the range for that question here. Also in this part, they talk about all the time you can't use, or it's optional to use 2 till -2. It's better to have more numbers on both sides so you can see clearly, okay? Geometric transformation of absolute value functions. There is a lot of transformation here that you should know regarding this matter. However, they didn't give you anything to know or talk about it, because we have shifting, we have transformation, we got upward, reflection, stretching, comparison, a lot of these ideas here. What you gotta do now is that when they talk about what is the function and stuff, you need to understand what is the movement here. For example, if we have an absolute value that contain a negative like that, it means that it's horizontal shifting to the right side, okay? If it was positive, it's going to the left. If you see a number with a plus outside, it's vertical, going up. If it's minus, it's going down and vertical. If you see negative with it, it's a reflection. So here, it means that the graph is going to the left. So which one is it? This part here. This one is movement, transformation, 3 parts going down. So which one has it? That number 2. So this one going here. The last one is reflection. So it's being reflected here like that. And that's all, just that. They all talk about it. This is shifting to this and that, okay? So if we talk about this, is 1 unit movement to the right, okay? You can just draw it like that. 1, and you draw it like that. Just that, 1. For this part here, is that vertical transformation 2 unit up. So it means that you draw the line 1, 2, and you go up like that. This is the 2. Just that this one is a reflection and 3 units up. So it means that you go 3 unit up, 1, 2, 3. This is the 3, but you go down like that. These are the exercise. Here the answer is 4, negative 3 become 3. This one, both negative, you add them, you get 7. This one you get 7. This one you get 0. This one becomes 1.7. This one you just bring it down like that, or you can write it as 11, 33 plus 5, you get 38. Let's say the absolute value of function, evaluate it, solve it. This one has 2 answers. The first one will be 2y plus 3. And by the way, sometimes they change the letter. So here we have 2y equal 4 and the y equal 2. That's the first number. The second part of it would be 2y equal 2y plus it by 3 equal negative 7, and 2y equal negative 10. So y equal negative 5. That's the answer for this part here, this one and that one. The other question like that. However, this part, you move it to the right side, you see it will be 2x minus 3 equal negative 8. So it has no solution because it's negative, just like that. For this one has one solution. It will be 2y minus 1 equals 0. You get 2y equal 1 and y equal 1 over 2. And that's the answer for this question. Do these formula have any solution? Write the reasons. This one, yes, it has. But when we put this one, it will be positive. It has 2 solutions. But this one, no. Because when we put it there, it will be negative 11. And negative doesn't count. This one says that you determine the domain of the range of the following. So the domain here is R, and the range, I think that it's vertical transformation 3 units up. So it will be, so it will be y bigger than 3. Okay. This one is a reflection. There's 3 things in it. Reflection, and moving to the left. To the left and 1 unit down. So in this case, you can graph it like that. First thing, we have 1 unit down and 4 unit to the left, 1, 2, 3, 4. So it will be here, and we have a reflection. So it will be like that. So in this case, we have negative 4 and negative 1. I think the domain is R. But the range, it will be between, I think, negative 4 and negative 1. I think that's something like that. It will be negative 1 bigger than or equal to y. I think so. I'm not sure about it, however. For this case, the domain for this question is R as well. This one is a transformation to the right side. So it will be, if I'm not mistaken, y bigger than 2. This part here, have an idea, which is inside of that one, there is a movement. So 3 unit up. For the inside, just equal by 0. You can negative x, negative 5 equals 0. So negative 5 equal x. So the x is negative 5. So it means that 5 unit to the left and 3 unit up. So it will be like this. 5 unit, 1, 2, 3, 4, 5. And 3 unit up. So it will be here and going this way. So it will be, the domain will be R. The range will be y bigger than or equal to 3. Okay, now let's say find the following graphs using geometric transformation absolute value function. So I see that there is one movement up and just a transformation vertically. So you can say y equal absolute value of x plus it by 1. That's the answer. For this one, we see two movement to the right side and one movement up. It means that y equal x minus 2 plus it by 1. Okay. It says that the absolute value, and choose the following correct answer. The absolute value of negative 5 is this one here, not these. Okay, number 2, which of these equation has no solution? This one here. Okay. Which of these graph represent the absolute value function of y negative x minus 2 in the absolute value plus 1? X minus 2 mean 2 movement to the right and 1 movement up, so it means this one here, T. And that's it for today's lesson.